And now, dear grade 11 students, after we've seen what happens if delta is negative, if delta is 0, let's see what happens if delta is greater than 0. So if delta is positive, so let's make a little revision for what we mentioned previously. If delta of a quadratic function is negative, then there are no real roots and the function takes the sign of a. If delta of a quadratic function is 0, then there is one double root, and the sign before the root and after the root on the table of signs is according to the sign of a, so it takes the sign of a. Here, if delta is negative, if delta is positive, and here is the third and the last case. So if delta is greater than 0, which means positive. Here is the rule. Of course, we are going to see the example, to study the curve, and go back to the rule to understand it more and more. And then we are going to get the idea where does the table come from. Let's start. Here is the quadratic function that's equal to x squared plus x minus 2, and here is its curve. Notice that part of the curve is above the x-axis, which means positive, and part of the curve is below the x-axis, which means negative. Negativity is below x-axis, positivity is above x-axis. So again, notice that the curve, part of the curve is above the x-axis and part of the curve is below the x-axis, and here are 2 points of intersection with the x-axis, and these are the roots as well. So the first root is minus 2, the second root is 1. Let's study this curve from minus infinity till minus 2. So as we move here from minus infinity till minus 2, so x is moving along the x-axis, don't forget. As we move from minus infinity till we reach minus 2, where is the curve? Look at the curve. The part of the curve is above the x-axis, so the function is positive. Where is also a part that's above the x-axis? It's when we move from 1 to plus infinity. So if x is moving from 1 to plus infinity along the x-axis from the point of intersection to plus infinity, notice the other part of the curve that is above the x-axis, so that means that the function is positive. Now, where is the curve below the x-axis? Let's change the color. The curve is below the x-axis in this region here. That is bounded between, for x I mean, is bounded between minus 2 and 1. Now at minus 2 and at 1, the function equals 0, or the ordinate of the points are zeros. So from minus infinity till minus 2, from 1 till plus infinity, the function is positive, the curve is above x-axis. Between minus 2 and 1, as you see here in the green color, the curve is below x-axis, which means that the function is negative. Now at minus 2 and at 1, it is 0, which means that the curve cuts the x-axis at these values minus 2 and 1. Now how do we represent this all of these ideas mathematically? C means the curve is above x prime x on when x belongs minus infinity minus 2 open, so when x belongs to minus infinity minus 2 and or 1 plus infinity, so we represent it by union 1 plus infinity. So again, C is above x prime x on this red part here and here, so from minus infinity to minus 2, union from 1 to plus infinity. C cuts x prime x at the roots, which are minus 2 and 1. So when x equals minus 2 and x equals 1, c cuts the x-axis and not a tangent, it just cuts the x-axis. Now finally, c is below x prime x on the interval minus 2 and 1 and opened on all intervals. Okay? Now let's go back to delta, to a, and to discover the rule. Delta for this function, that's x squared plus x minus 2, is 9, which is positive. Using the calculator, we can find the roots that are minus 2 and minus 1. So, delta is positive. Then we are going to construct the table, putting the roots that are distinct on the table in the increasing order. We start with minus infinity, minus 2, and 1. So we arrange the roots in the increasing from the smaller to the larger. We put zeros because f of x equals or t of x equals to 0 at this root. And now let's use the ideas here. From minus infinity to minus 2 and from 1 to plus infinity, c is above, which means positive. So in this region and in this region, this is from minus infinity to minus 2. This is from 1 to plus infinity. The sign of the quadratic function is positive. At minus 2 and 1, there is intersection, that's why we put zeros. C is below x prime x on minus 2, 1, this means negative. So between minus 2 and 1, we put the negative sign. And thus we got plus, minus, plus. Let's go back to the rule here. The rule says, if delta is positive, we have to look at the sign of a, and here the sign of a is positive because a is 1. So if delta is positive, we put the roots, we can find them using the calculator. We put the roots on the table, we put zeros on the column holding the roots, minus infinity, plus infinity. Same, opposite, same. This is the secret word that you are going to memorize. S-O-S. Same, opposite, same. Same to what? Opposite to what? Let's see. Same sign as A. Opposite sign of A. Same sign as A. So whenever you put the roots, you don't need all of this. You just find delta. If it's positive, you directly find the roots. You continue finding the roots using the calculator. You put them in the increasing order and you have to put same, opposite, same, referring to A. So if A is positive, you put here plus, plus, and here you put minus. If A is negative, you put here minus, minus, and here you put the opposite of sign of A, which is plus. So that's the rule. So again, if delta is positive, we just find the roots. We put them on the table in the increasing order. We consider the sign of A and we apply the rule S-O-S. Same as A and opposite in between the roots. Now, where does, if we don't want to understand things graphically, where does the idea of same, opposite, same come from? Let's explain it analytically. Why SOS? Here is the function we are studying, that is x squared plus x minus 2. If we factorize it using the calculator or if we find the roots using the calculator, the roots are minus 2, 1, exactly as here. Now, I made this table in order to explain more and more analytically without using the graph why same, opposite, same. So if we want to prove it analytically, we have to use the sign of a product, okay? So x plus 2 is the first factor, x minus 1 is the second factor, knowing that if minus 2 is a root, then the factor is x plus 2. If 1 is a root, then the factor is x minus 1. So if you calculated the roots using the calculator, you can directly find the factors by writing the opposite sign of the roots between x and the number. Now, we put 0 for x plus 2 at minus 2, because minus 2 is the root for x plus 2. And as you know, before the root we have the opposite sign of x, and after the root we have the same sign of x, so minus plus plus. Now this is the factor x minus 1 whose root is 1, so we put the 0 at the root. And again, before the root we have to put the opposite sign of x, and after the root we put the same sign of x, so minus minus plus. Now multiplying the signs we get plus minus plus, and thus this is the case we were talking about, same opposite same. So here is t of x, which is the product of these two factors, and same as a we mean, which is 1, same opposite same. And here where the idea of same opposite same came from, if we are going to prove things analytically.